President Biden recently introduced the first publicly shown image from the James Webb Telescope, the largest and most powerful telescope ever launched into space. NASA's James Webb Space Telescope has just begun its mission, yet it has already revealed cosmic mysteries. Among these is Oumuamua, the first known interstellar visitor to our solar system. As the telescope captures its first true image, might Oumuamua's origin point to extraterrestrial life? What could this revelation mean for humanity's understanding of the universe? Join us as we uncover the startling secrets of Oumuamua, which may challenge everything we thought we knew about the cosmos. Oumuamua, the first known interstellar object to pass through our solar system, captivated the world in 2017. It was unlike anything previously observed. The Pan-STARRS Observatory identified Oumuamua, challenging accepted theories and sparking intense scientific discussions. This mysterious visitor generated more questions than answers, with its peculiarities deepening the mysteries surrounding its origin and nature. The fact that Oumuamua's source remains unknown adds to its fascination. Although it arrived in our solar system via the Lyra constellation, the exact location of its parent star system is still unclear. The object's extraordinary speed relative to the Sun suggests that it did not originate within our solar system. It may have been traveling through the galaxy for millions, if not billions, of years before reaching us. The exact flight path and origin of Oumuamua are unknown since the stars it might have interacted with have moved from their original positions, making it difficult to trace its stellar origins. Its approach from above the ecliptic plane, which is the plane in which most planets and interstellar objects revolve, further complicates the situation. Due to its unusual trajectory, Oumuamua did not come into close contact with any of the solar system's main planets, leading scientists to hypothesize that its journey through space was largely unobstructed. Researchers have utilized data from the European Space Agency's Gaia spacecraft to try to trace Oumuamua's path, suggesting it could have originated from one of several nearby star systems, including the red dwarf star H3757, the sun-like star HD 29224, and two additional stars with less familiar names. Despite these efforts, the object's exact origin remains a mystery. Another enigma surrounding Oumuamua is its physical appearance. While many artistic interpretations have been created, there is no conclusive image of what it looks like. Observations have suggested that Oumuamua is elongated, being approximately 10 times longer than its width, which is exceptionally unusual compared to other known interstellar objects. Most comets and asteroids have a length-to-width ratio of about 1:3. Its brightness changed by a factor of 10 every 8 hours, indicating both significant elongation and rapid tumbling motion. As Oumuamua moved through space, it seemed to flash due to this tumbling action. Unfortunately, because the object was only visible for a short time, scientists have yet to obtain a detailed image of it. Adding to the mystery, Oumuamua experienced an unexpected acceleration as it neared the Sun. Observations from the Hubble Space Telescope and other ground-based observatories revealed a slight increase in its speed, altering its anticipated course. This acceleration could be explained by outgassing, a process where gas and dust are ejected from an object's surface, as seen in many comets. However, no direct evidence of outgassing was found with Oumuamua. Some scientists theorize that this acceleration might have been caused by gas jets or the sublimation of strange materials like solid hydrogen or nitrogen ice. These theories, however, remain speculative. Oumuamua's journey through our solar system was brief. It is currently speeding away at about 26 kilometers per second and is expected to leave our solar system in more than 20,000 years, a blink of an eye in galactic terms. The short window of observation and the object's rapid velocity present significant challenges for future research. Even Voyager 1, the fastest spacecraft ever launched, traveling at 16.6 kilometers per second, would find it impossible to catch up with Oumuamua using current technology. Advanced concepts like laser propulsion and solar sails would also struggle to reach it in time. The peculiar properties of Oumuamua have sparked numerous ideas about its origins. One possibility is that Oumuamua is a fragment of a larger celestial body, like a planet or moon, ejected from its host star system during a near collision with another star. This theory suggests that Oumuamua may have drifted through interstellar space for millions or billions of years before encountering our solar system. Another hypothesis is that it was part of a larger object that was destroyed by tidal forces as it neared a star, explaining its elongated shape. Avi Loeb, an astrophysicist, has proposed a more extraordinary theory. Oumuamua could be an example of alien technology. Loeb has suggested that its unusual shape and behavior might be best explained by an artificial origin. He speculates that Oumuamua could be a solar sail or even a component of a Dyson sphere, a hypothetical structure designed to harness energy from a star. According to Loeb, such an object would require advanced technology to construct and would challenge our understanding of natural celestial bodies. The mystery of Oumuamua continues to fascinate scientists and scholars. Discovered in October 2017, it has become a topic of intense debate in the astronomical community due to its peculiar properties. New findings have raised fresh questions about its composition, structure, and possible technological origins. As scientists continue to study Oumuamua, they face many possibilities. If the object's composition differs significantly from anything observed in nature, it could indicate that Oumuamua is not a typical celestial body. For instance, if its structure resembles that of a spacecraft, it could be more advanced than a simple rock or asteroid. To truly understand Oumuamua, more detailed data is required, especially if there are any signs of technology. Avi Loeb, a leading expert in this field, has stated that catching up to Oumuamua with a spacecraft would be an extremely difficult task. The object's immense speed, estimated at 315,000 kilometers per hour, 196,000 miles per hour, combined with its trajectory, makes intercepting it with current technology nearly impossible. Despite these challenges, various missions have been proposed to approach Oumuamua. These concepts aim to address the considerable hurdles of high-speed travel and precise aiming. Current chemical rockets lack the capability to reach the speeds necessary to overtake Oumuamua, but new methods could potentially make this possible. One such approach involves using gravitational slingshots or flybys, a technique also known as a gravity assist or Oberth maneuver. This method uses the gravitational fields of large celestial bodies, like the Sun or Jupiter, to increase a spacecraft's speed. By flying close to these massive objects and harnessing their gravitational pull, spacecraft can significantly accelerate. This strategy has been successfully used in previous missions, such as the Voyager probes, to propel them towards the outer planets. Adam Hibbard, a freelance software developer from the United Kingdom, has developed potential mission plans to intercept Oumuamua using his expertise in trajectory optimization. After learning of Oumuamua's discovery, Hibbard, along with Project Lyra, proposed several mission designs. One idea involves launching a spacecraft in 2030 that could reach Oumuamua in about 22 years. Initially, the team considered missions requiring close encounters with the Sun, which would necessitate significant shielding to protect the spacecraft from extreme heat. However, this strategy would severely limit the spacecraft's cargo capacity. As a result, Hibbard and his colleagues began exploring other options, avoiding close solar encounters and instead relying on Jupiter's gravity for a slingshot boost. Scientists identified two viable methods for reaching Jupiter from Earth, both involving a series of slingshot maneuvers around the inner planets. These approaches would allow the spacecraft to gain enough velocity to use Jupiter's gravity to propel it toward Oumuamua. This strategy would result in a mission duration of about 31 years, which is 9 years longer than trajectories requiring close solar passes. Marshall Eubanks, chief scientist at Space Initiatives Incorporated and a member of Project Lyra, is enthusiastic about sending a spacecraft to Oumuamua or other interstellar objects. He notes that while missions to nearby stars are being considered, Oumuamua's relative proximity makes it a far more accessible target, even after a century. President Biden recently introduced the first publicly shown image from NASA's James Webb Space Telescope, the largest and most powerful ever launched into space. The telescope has barely begun its mission, yet it has already revealed cosmic mysteries. Among them is the interstellar object Oumuamua, the first known visitor from another star system to pass through our solar system. As the telescope captures its first true image, could Oumuamua's origin point toward extraterrestrial life? This raises profound questions about humanity's understanding of the universe. The discovery of Oumuamua in 2017, identified by the Pan-STARRS Observatory, sparked intense scientific debate due to its unique characteristics. This interstellar visitor challenged existing theories and generated more questions than answers. One of the most intriguing aspects of Oumuamua is its unknown source, as scientists have yet to pinpoint its precise origin, despite it arriving from the direction of the Lyra constellation. Oumuamua's incredible speed relative to the Sun suggests that it did not originate in our solar system. Instead, it could have been traveling through the galaxy for millions or even billions of years before arriving here. Determining its exact path and origin remains difficult, as stars move over time, making it hard to trace its stellar home. Complicating matters further, Oumuamua approached our solar system from above the ecliptic plane, which is the general path followed by most planets and interstellar objects. This unusual trajectory meant that it didn't come into close contact with any of the major planets in our solar system, suggesting that its journey through space had been largely unobstructed. Researchers have used data from the European Space Agency's Gaia spacecraft to try to trace its path, but no conclusive results have been obtained. Various star systems, such as the red dwarf H3757 and the sun-like star HD 29224, have been considered, but its exact origin remains a mystery. Adding to the enigma is Oumuamua's strange physical appearance. Observations suggest it is elongated, with a length-to-width ratio much higher than typical comets or asteroids. Its brightness fluctuated as it tumbled through space, making it appear like a flashing light. Despite these observations, no detailed images were captured due to its brief visibility. Another mystery is the unexpected acceleration it experienced as it approached the Sun. Normally, such acceleration is attributed to outgassing, where gas is released from a comet's surface. However, no evidence of outgassing was found for Oumuamua. Some scientists theorized that its acceleration could have been caused by other factors, such as gas jets or the sublimation of materials like hydrogen or nitrogen ice. These theories remain speculative as the object's short observation window left many questions unanswered. Oumuamua is now speeding away from our solar system at about 26 kilometers per second and is expected to leave our system in over 20,000 years, a blink in galactic terms. With its fast velocity and our limited technology, catching up with Oumuamua presents major challenges. For instance, Voyager 1, the fastest spacecraft ever launched, travels at only 16.6 kilometers per second. This makes intercepting Oumuamua with current technology nearly impossible. Even advanced concepts like laser propulsion and solar sails would struggle to achieve the required speed. As a result, various theories about Oumuamua's origin have emerged. Some suggest it could be a fragment of a larger celestial body, such as a planet or moon, ejected from its host system. Others propose that tidal forces from a close encounter with a star could have elongated its shape. A more controversial idea comes from astrophysicist Avi Loeb, who speculates that Oumuamua could be an artificial object, possibly a solar sail or a fragment of alien technology. The ongoing mystery of Oumuamua has continued to captivate scientists and the general public alike. With so many unanswered questions about its composition, structure, and behavior, some experts believe it could provide groundbreaking insights into both natural and potentially artificial celestial objects. However, investigating it more closely would require a significant technological and financial investment. Given its rapid speed, even advanced spacecraft may struggle to catch up. Nevertheless, ideas such as gravity assists, which involve using the gravitational pull of planets like Jupiter to increase spacecraft speed, are being considered as potential methods for intercepting Oumuamua. One proposed mission, Project Lyra, aims to send a spacecraft by 2030, which could reach Oumuamua in about 22 years. Another approach suggests using Jupiter's gravity rather than relying on the Sun, which would take around 31 years. These efforts reflect the growing interest in studying interstellar objects like Oumuamua before they disappear from our reach. Marshall Eubanks, chief scientist at Space Initiatives Incorporated and a member of Project Lyra, argues that missions to objects like Oumuamua are more feasible than expeditions to distant stars like Proxima Centauri, which is 4.24 light-years away. Financial constraints pose another hurdle, with missions similar to NASA's New Horizons, which explored Pluto, costing around $1 billion. There is also the risk that such a mission could yield disappointing results if Oumuamua turns out to be nothing more than an ordinary rock. Despite these challenges, the prospect of discovering whether Oumuamua is a natural object or a piece of alien technology continues to inspire mission concepts. One particularly intriguing idea is the von Neumann probe, a self-replicating spacecraft that could explore the galaxy independently. Such probes, named after mathematician John von Neumann, would use local resources to make copies of themselves, potentially spreading across the galaxy. Another speculative concept is the Matryoshka brain, an enormous computational network composed of Dyson spheres, structures that harness energy from stars. Both ideas are related to the simulation hypothesis, which suggests that our universe could be an artificial simulation created by an advanced civilization. More recently, the James Webb Space Telescope made another groundbreaking discovery, detecting carbon in a compact galaxy just 350 million years after the Big Bang. This discovery, which challenges previous predictions, suggests that carbon, a building block of life, may have formed much earlier than expected. The findings imply that the early universe may have been more conducive to life than previously thought. This revelation could also reshape our understanding of extraterrestrial life, which may be based on entirely different materials or structures than life on Earth. The search for extraterrestrial civilizations continues to be one of the most fascinating and perplexing scientific endeavors. Despite the discovery of thousands of exoplanets, no conclusive evidence of intelligent life has yet been found, leading scientists to revisit the famous Fermi paradox. The Drake equation, developed in 1961, remains a key tool in estimating the probability of finding extraterrestrial civilizations by factoring in variables such as the rate of star formation, the number of planets capable of supporting life, and the likelihood of those planets developing intelligent beings capable of communication. While life has emerged on Earth, the rarity of intelligent life forms suggests that civilizations like ours may be incredibly rare.